वो तो सर क्या होती है कि जो अपना प्रथम पद होता है, ये तो अपन ये मानते हैं। अब इसमें क्या होता है, 6 दूनी 12 दूनी 24, तो ये क्या हो रहा है, अंतर समान है। जो इसमें 3 का अंतर है, इसमें 6 का अंतर है, इसमें 9 का अंतर है। अंतर समान है, जो समांतर श्रेणी जो है नहीं। अब ये क्या है, 3 के बाद 6, तो यहाँ अंतर नहीं है, लेकिन क्या 3
म्यूट
गुणा
करिए।
गुणा करो 2 गुणा करो 2, तो ये
हमारे
जो हो रहा है ये कहलाता है सारणिका।
जितने भी
ये कहलाता है
हमारे स्टूडेंट्स
सारणिका।
कनेक्टेड है गूगल मीट से, प्लीज अपने आप को म्यूट कर लीजिए। वी आर गोइंग टू स्टार्ट द प्रोग्राम नाउ। So if you are connected through Google Meet and still unmuted, please mute yourself. All those who are connected through Google Meet to us, please mute yourself. We're going to start the program shortly, in a minute, in a moment. Take, ready? Good morning, everyone. Respected chief guest for today's function, Sri Professor K. Subramaniam sir, Professor and Center Director, Homi Bhabha Center for Science Education. Respected Principal sir, Sri Nityanand Pradhan sir, Principal RI Bhopal. Respected Garg sir, respected Thomas sir, respected Mandal sir, and all the heads, respected all the heads, deans of RI Bhopal, and their colleagues, their friends. Today, the country celebrates National Mathematics Day in the memory of Sri Srinivasa Iyengar Ramanujan, a great mathematician for India. You all know, we all know, India has contributed a lot to the world's education, and in mathematics, the contribution has been since Aryabhatta of ancient India to modern time, through the works and through the works of Ramanujan. Now let us start the program of National Mathematics Day with our RI Gan. I request the studio team to play RI Gan that demonstrates our work, what we do in the field of education at RI Bhopal. To the studio team for RI Gan.
जीवन पथ आलोकित करती ज्ञान की मशाल, विद्या का संचार कर रहा आरआई भोपाल, आरआई भोपाल। जीवन पथ आलोकित करती ज्ञान की मशाल, विद्या का संचार कर रहा आरआई भोपाल, आरआई भोपाल। श्यामला पहाड़ी में स्थित है शिक्षा का यह धाम, शांति ज्ञान के उद्गम को हम करते सभी प्रणाम। श्यामला पहाड़ी में स्थित है शिक्षा का यह धाम, शांति ज्ञान के उद्गम को हम करते सभी प्रणाम। भारत के पश्चिमी प्रांतों का ये करता प्रतिनिधित्व, नवाचार शिक्षण पालन का है पूरा दायित्व। अनुसंधान प्रशिक्षण को हम मिलकर रहे समान। जीवन पर आलोकित करती ज्ञान की मशाल, विद्या का संचार कर रहा आरआई भोपाल, आरआई भोपाल, आरआई भोपाल। शिक्षण की पूर्ण कलाओं से हम संपूर्ण संवरते, विद्या उपवन की खुशबू से हम हैं सदा महकते।
शिक्षण की पूर्ण कलाओं से हम संपूर्ण संवरते, विद्या उपवन की खुशबू से हम हैं सदा महकते।
संग साथ मिल बने सुशिक्षित ये संकल्प हमारा, NCERT का सपना है उन्नत हो भारत प्यारा।
बच्चों के मन में उपजे सुलझे सभी सवाल। जीवन परालौकिक करके ज्ञान की मशाल, विद्या का संचार कर रहा राई गोपाल, राई गोपाल।
सामाजिक समरसता, सेवा और व्यवहारिक ज्ञान, अंतर मन आलोकित हो आदर्शों का मान।
सामाजिक समरसता, सेवा और व्यवहारिक ज्ञान, अंतर मन आलोकित हो आदर्शों का मान।
मानवता के मूल्य सिखाना शिक्षा का उद्देश्य, हो पूर्ण विकास निरंतर हो प्रायोगिक परिवेश।
अपनी अतुलित ऊर्जा को दे निर्माणों में जीवन परालौकिक करके ज्ञान की मशाल, विद्या का संचार कर रहा राई गोपाल, राई गोपाल। जीवन परालौकिक करके ज्ञान की मशाल, विद्या का संचार कर रहा राई गोपाल, राई गोपाल, राई गोपाल, राई गोपाल, राई गोपाल।
Thank you very much to the studio team for showcasing our work. Now, may I request our respected principal sir, Garg sir, Thomas sir, to take blessings of Goddess Saraswati and garland the photograph of Srinivasa Ramanujan sir to formally commence the program. Ramanujan was also popularly known as the man who knew infinity. And it's a surprise, dismal surprise to all of us that at that time, Ramanujan did not receive any formal education. Just he knew a few concepts of mathematics, and that brought him to so much investigation, so much study in the field of mathematics that he brought laurels to India and has given a lot to the world. Now we have with us Miss Shivani Dixit, a student of RI Bhopal. I request her to unmute and present a life sketch of Srinivasa Ramanujan. May I request Shivani Dixit, a student of RI Bhopal, to unmute and present a life sketch of Sri Ramanujan. Shivani, over to you. Shivani? Yeah, her screen is busy.
Yes, sir.
Please unmute. Please unmute yours.
Sir, I think I have unmuted myself. Am I audible?
Shivani का voice थोड़ा देखो. She is speaking.
Sir, am I
Shivani,
audible?
if you will
Am I
speak-
audible?
Yes, yes. Now you're audible.
yes.
Please go ahead.
Am I audible, sir?
Yes, yes. Please go ahead. You're audible.
So thank you, sir. A very good morning to one and all present here. We have gathered here on the 133rd birth anniversary of Sir Srinivasa Iyengar Ramanujan. I feel honored to get this opportunity to present the life sketch of Sir Ramanujan. He said, "An equation for me has no meaning unless it expresses a thought of God." He is known as an all-time great Indian mathematician who was born on 22nd December 1887 in Erode in Tamil Nadu. Once his teacher said that when 0 is divided by any number, the result is 0. Ramanujan immediately asked his teacher, whether 0 divided by 0 gives 0? This is an anecdote which shows his early signs of genius. He passed primary examination and stood first in the district at Town High School in Kumbakonam. He mastered advanced trigonometry written by S.L. Looney at the age of 13 years. He was invited to England to improve his works by G.H. Hardy and J.E. Littlehood, who were great mathematicians. Hardy and Ramanujan were two opposite personalities. As Hardy was an atheist and believed in mathematical proof, and on the other hand, Ramanujan was deeply religious and believed in the first Indian mathematics, and he also became a fellow of the Royal Society. He is best known for a number of works. A few of them are Landau Ramanujan constant, Mach theta functions, Ramanujan conjecture, Ramanujan prime, and many more. He is also known for his magic square. This square may appear to you like a normal magic square, but this was created by Sir Ramanujan. So let's find out what is great about this square. As we can see that the sum of numbers of any of this row adds up to 139. Okay, let's move further. The sum of numbers of any of this column also adds up to 139. Okay, let's further explore. The sum of the numbers of these diagonals also add up to 139. But you may think that this is present, these properties can be exhibited in any of the normal magic square. So let's further explore what is unique about this magic square. Just look at this. The sum of the numbers of the corners are also equal to 139. Further moving on, the sum of the numbers in the identical colored boxes also adds up to 139. And not only this, the sum of these similar colored boxes also adds up to 139. And the sum of this yellow color square numbers also add up to 139. And if you doubt, you can even use your calculators to add them, because I have already done that. Even the sum of these quadrants, as you can see, they are different colored. These numbers also add up to 139. And not only this, the numbers present in this green square also add up to 139, and the similar goes with this pink colored box. But not only this, there is one more thing that is special about this box. As we all know that Sir Ramanujan was born on 22nd December 1887, this magic square represents that date as well. Just look at this, 22nd December, that is 12, 1887. We must be proud that such a great Indian mathematician was born on our motherland. He had a unique ability to find mathematics everywhere. Once Ramanujan and Hardy arrived at Ramanujan's residence in a cab number 1729. For Hardy, it was a normal number with no such characteristic. But Ramanujan found and said that it is a very interesting number. There's a mystery behind this number. This is the smallest natural number that can be represented in two different ways as sum of two cubes. As you can see, it can be expressed as the sum of 1 cube and 12 cubed and 9 cubed plus 10 cubed as well. And this incidentally also the product of three prime numbers, that is 7, 13 and 19. He also gave the largest known number. So we can say that Ramanujan was indeed a friend of numbers. He had a tough life in England due to various reasons. Due to unavailability of pure vegetarian food in England, he was too busy with the calculations that he often neglected the food. And also, the cold and damp climate disturbed his life. He also was suffering from tuberculosis, so he decided to come back to India on 20. So he came back on 27th February 1919. And unfortunately, he passed away on 26th April 1920 at Kumbakonam, Tamil Nadu. Seeing his contributions and his work, the Government of India declared the year 2012 as the National Mathematics Year, and the date 22nd December, being the birthday of Sir Ramanujan, was declared to be celebrated as the National Mathematics Day. So thank you everyone for very patiently listening to me. Thank you.
Was listening to Shivani, I always regret why I didn't do much in mathematics. I should have learned more of mathematics. There's such a magic is there in mathematics, and the way this squared was presented, I was really mesmerized by the way Ramanujan has worked on those few list of numbers, selected around 16 numbers or 20 numbers, and how those numbers completely in any way you add it in any manner and it will lead up to the particular number. So thank you, Shivani. And now may I request our respected principal sir, Sri Nityanand Pradhan sir, to deliver his on the occasion of National Mathematics Day. Sri Nityanand Pradhan, Principal, RI Bhopal.
Thank you, Dr. Ganga. Respected Professor K. Subramaniam, today's chief guest from Homi Bhabha Center for Science Education, Tata Institute of Fundamental Research, my esteemed colleagues from this institute, the program coordinators, Dr. Ashwini Garg and Ajit Thomas, and the resource persons, and esteemed delegates. First of all, I would like to wish you all a happy National Mathematics Day. As has already been told by Dr. Ganga, the comparer, and the Shivani, our student, about this Mathematics Day, that this country is celebrating today, this 22nd December, as National Mathematics Day since 2012. And she has also said that with a very short span of life, he breathed his last at the age of 32 only. So within this time, short period of his life, without formal education, he has contributed immensely to the field of education. by contributing many theories, by bringing out many theories like theory fractions, infinities, number theories, and mathematical analysis, etc. And we should be happy that not only Srinivasan Iyengar Ramanujan, but also many scholars since ancient times have contributed to the field of mathematics. When we talk of contribution to the field of mathematics, it means to the field, to the humanity. So it is not confined to any evolution of a particular theory, particularly theory of mathematics is not confined to the nation. It is a contribution to the humanity. And you must all aware that the zero is discovered by the Indian mathematician Aryabhatta. There are ancient mathematicians like Brahmagupta, Mahavira, Bhaskara, and so on. So the basic purpose of this celebration of this Mathematics Day is to raise the awareness of among the people about mathematics or importance of mathematics for humanity. I think it is somewhere missed in our curriculum, particularly in our school curriculum. Of course, our new National Education Policy 2020 keeps importance on foundational numeracy. The first in the first 5 years of education, numeracy is highlighted. That is important because due to various reasons, particularly use of technology like computer and so on, students have are neglecting computation skills, and that has been highlighted. But for the first 5 years, by the grade 3, the basic mathematical operations like addition, subtraction, and so on. But beyond that, the humanity aspect, the contribution of mathematics to humanity or different development sectors, the use of mathematics, different development sectors or human aspect of mathematics is somewhere missing in our school curriculum. And till the end of school education, we put only emphasis on computation skills. This computation skills is important, no doubt, but that is not the only use of mathematics, or that is not the only importance of mathematics. So the student who knows only, who has only computation skills, he is known as a good student in mathematics. But analysis of facts or mathematization or logical thinking, logical analysis, systematic thinking, these are not emphasized. And often we say that the students who are the students of mathematics, they are very logical, they are very analytical, and they are very systematic in their approach. So that is what is, if I correctly understand, because I am not a student of mathematics, that is what is called mathematization. And that is somewhere lacking, which also our school curriculum framework focuses. So this day is celebrated not only to develop computational skills, to make the students able to develop computational skills, but also to realize the importance of mathematics in our not only day-to-day life, but also in all development sector, whether it is education, whether it is economy, whether it is health, or any other sector. So this is how I perceive the importance of mathematics in our life. And with this, I thank the mathematics sections of Department of Science and Mathematics Education of RI Bhopal for celebrating this, and as organizing this national conference on mathematics education. As you all know, this is organized, this national conference on mathematics education is organized on rotation basis amongst 8 constituents of NCRT, including 5 regional institute of education, CIET, NI, and PSCIV. With this, I once again thank the department, the mathematics section of Department of Science and Mathematics Education of this institute for celebrating it towards the end of this conference. Thank you.
Thank you very much to our respected principal sir for highlighting the importance of mathematics in school curriculum, in school education, and the importance of this day for our day-to-day life. Now it's time to listen to our chief guest, but before I go and invite the chief guest, I would like to request Dr. Ajit Thomas from the Department of Mathematics to give a formal address of our chief guest and give a brief introduction about our chief guest. So may I request Ajit Thomas sir to introduce our chief guest.
The most honorable chief guest for today's program, Professor K. Subramaniam, Professor and Center Director, Homi Bhabha Center for Science Education. The esteemed Principal of Regional Institute of Education, Professor Nityanand Pradhan. The coordinator of this 9th National Conference on Mathematics Education, Professor Ashwini Kumar Garg, all respective head of departments and all colleagues who are joined and all the participants who are live with us. First of all, I want to wish a happy Mathematics Day. So it's my proud privilege to introduce about the chief guest for today, Professor K. Subramaniam. He is the professor and center director at Homi Bhabha Center for Science Education, Tata Institute of Fundamental Research. His area of works is research in mathematics education. Learning stands for core topics in middle school, mathematics, algebra, fractions, and proportional thinking, measurements, integers, decimal, models for professional development of mathematical teachers, connecting out of school mathematical knowledge with school learning. And he had held a number of positions since 2000 to introduce some key positions he has held. From 2015 to 16, he has been the Dean of HPCSC, TIFR Mumbai. To 2015 to present, he is the professor at the same institute, Homi Bhabha for Center of Science Education, Tata Institute of Fundamental Research. He has earned his PhD from Indian Institute of Technology, Bombay, and he has a wide contribution in the research and in the field of mathematical education. To name some professional recognition he holds, he has been a plenary speaker in PME 43 in 2019, invited to a plenary panelist in ICME 14, invited editor for the India section for the first source book of Asian research in mathematics education, member of International Program Committee, reviewer of International Journal of Research in Mathematical Education, International Journal on Mathematics Education Review for international conferences, international reviewer of large funded project, numeracy and chair in South Africa. To mention some professional recognition, he is the member advisor board of Mathematical Teacher Association India from 2018, country representation for India on International Commission for Mathematics Instruction, coordinator of India's national presentation at ICME, chairperson Curriculum and Syllabus Committee in Mathematics for Maharashtra State, member of Mathematics Textbook Committee for Maharashtra, member of Governing Council, Academic Council, and various academic institutions, member of editorial boards of research journal Contemporary Education Dialogue from 2010 to 18, and he has a number of publications. So the list goes if I keep on saying. So I just want to welcome Sir. I don't want to take much time and want to welcome Sir for the keynote address. So we are all keen to listen to you, sir. Thank you very much.
Thank you very much, Dr. Ajit. Should I start? Can you hear me? Am I audible?
Yes.
Yes, okay, yeah. Thank you. It's a great pleasure and honor to be here. Principal Pradhan, Professor Garg, Dr. Ajit, other colleagues from RIE, Shamla Hills, Bhopal, delegates to the conference, so colleagues and from the mathematics education community at large. I hope you're having a wonderful conference. It's a great privilege and honor, as I was saying, that to be invited to give a talk on this very special day, which is the National Mathematics Day and commemorates the birth anniversary of the great mathematician Ramanujan. I thank the organizers for giving me this privilege and this opportunity to talk to you. Of course, today is a day when we talk about mathematics, enjoy doing some mathematics, especially inspired by Ramanujan and so on. But there are plenty of talks of this kind today. I'm sure many of them will be available for viewing even later on YouTube. Even if you're attending the conference today, you will have the opportunity to listen to a great talk later this evening. I think it's at 7 p.m. organized by the Kerala School of Mathematics, where Professor Manjul Bhargav is giving a talk. And I'm sure that will focus on some very interesting mathematics. Today, however, the theme that I have chosen is of mathematics education, which is, of course, my own area of work. And I thought that would be appropriate to talk about, given this audience and given this setting of NCERT. This is really speaking the community of mathematics educators and educationists. So that's what my talk is going to be about. Maybe some other occasion I could speak about mathematics, but today it's about mathematics education. And without further ado, let me start. I have a presentation of slides. So I will start my presentation. I hope you can see the screen. Is it visible and clear? Can somebody respond?
Yes, sir.
Yes, sir.
Okay, thank you so much. Thank you so much. Yeah. So that's the topic that I'm going to talk about. The mathematics curriculum reform, carrying the agenda forward. Of course, there has been special efforts at reforming the mathematics curriculum, especially at the school level, also at the higher education undergraduate level for a long time, many decades in independent India. This has intensified in the last 2 or 3 decades, one might say. And of course, the immediate context for thinking about this, for recollecting this, is the new education policy, the national education policy that has been announced in 2020, and which will, of course, give, in its wake, we will have a new curriculum framework and new textbooks and so on. Of course, there are some major revisions and reform of the education system as a whole, which has been suggested. So that provides the context, although I will not be focusing exactly on directly on what NEP 2020 says, but it kind of provides the background for my talk today. I will start speaking, and I believe I can speak. We have about an hour and 15 minutes. I will take maybe about 45 minutes or so. But if you have any questions in between, please feel free to interrupt. I will stop in between and check the chat box, which I cannot see right now because I can only see my slides on full screen. But I will check the chat box from time to time. And if you have any queries and questions, please put it there and I can address that as I go along. So these are some landmarks in education policy and curriculum reform. We have had 3 education commissions from the time from independence, which have looked at policy. The University Education Commission, also known as the Radhakrishnan Commission, which looked at higher education, Secondary Education Commission, or the Mudaliar Commission from 1956, which focused on school education, and a very comprehensive policy document popularly known by the name of Kothari Commission, or the National, that's in 1966. So a very detailed and long document that articulates nearly everything that one might wish to say. We have had 2 national policies on education, one in the mid-1980s, 1986, the National Policy of Education, and one, of course, announced this year, the National Education Policy 2020. I've highlighted the more recent developments in yellow. We have the Right to Education Act 2010, which is also an important landmark, shaping education as a whole and education policy. And we have had national curriculum frameworks on school education. We've had several of those, 1976, 1988, 2000, and we have had the more recent one, which is NCF 2005, or 15 years ago. All of these, of course, have looked at curriculum and put forth certain perspectives and views. I would also like to mention here the Yashpal Committee report, Learning Without Burden, which came out in 1995. Actually, this talk is based on a paper, or rather a chapter that I've written, and which is going to be published soon, hopefully, by Routledge in a collection. And please do follow my page on Google Scholar. You will, as soon as it's published, it will come up there, and you can certainly refer to it. If you need any, if you are not able to find the chapter, you can write to me. So my talk is largely based on that, though not entirely. The occasion, so when I wrote this chapter, I had occasion to look at the Yashpal Committee report closely and its connection with the NCF 2005. And I was struck that it really, this was in some sense the original motivation for much of what happened in NCF 2005. So one could say the inspiration came from that. I've discussed those links in detail in my paper, but I'll not be discussing that right now. Of course, if we have had so many education policies, the question also arises, I mean, have these education policies changed education? Really speaking, what have they achieved? Another question that comes up is, are the other policies announced really different from one another, or are they repeating more or less what the previous policy said? Another question that arises is, were the goals set by the successive policies achieved? Were they not achieved? Were they abandoned by the next policy? Were some new goals set up? What happened to the old goals? So this is again, so I think a lot of critical questions do arise, and to which we don't have very clear answers. And unfortunately, the new education policy is not very strong in terms of reviewing the changes that have happened and what gains we have made, what has not been achieved, what are the gaps, and so on from previous policies. That the historical perspective people have commented is not really strongly present, which again raises this question of what happens. Are we, sort of reinventing the wheel, restarting the effort every time? Another question that comes about is, of course, education has changed. Many things have changed over the decades. Great expansion has taken place. A lot of commercialization has happened. So are these changes the result of policies, or are they despite whatever policies have been announced? So the question is that do policies really impact or bring about changes in education? And I'd like to read to you some excerpts, which I'll do from time to time. I'll read some excerpts from the paper itself. So when we ask the question, what is common? Are these policies really different? And what have they achieved? So we see that nearly every policy document, so there is a lot of commonality. Nearly every policy document has prioritized enhancing teacher status and autonomy, raising public expenditure on education to 6% of GDP. This has become a kind of key figure. It was first mentioned in the Kothari Commission in 1966. So you can imagine that's nearly half a century ago. Ensuring quality in education, abandoning rote learning, syllabus reduction, reducing the impact of examinations, and so on. So these have been common things in many education policies. But even decades after these policies were declared, a large proportion of teachers are contract employees, even today. Public expenditure remains far below 6% of GDP. In fact, it has even reduced in recent years. Private educational institutions have expanded more rapidly than public ones at every level of education. Rote learning has taken an even firmer hold, and private coaching and examinations have become overwhelmingly the dominant feature of education in the country. In fact, now higher secondary education and coaching for competitive exams have almost merged in many metro cities in the country. So this sort of raises the question, what do these policies achieve, and do they really bring about the change that they intend? Of course, these are hard questions, difficult to answer, cannot be answered at one shot, but it does tell us of the need to take stock of certain things that have happened due to efforts which were intentional, directed, focused at reform. And what are those changes? How far have they gone? What are their limitations, and so on? So that's what I'm going to talk about today. So what did the most recent policy changes achieve, and what can we learn from studying these? And in particular, I will discuss the impact of NCF 2005 and the lessons that can be drawn from the efforts that went into that policy document. Okay. Let me just pause a bit and check if there's anything on the chat. Okay, so nothing so far. All right, so please do feel free to put something there. Okay, so I'd just like to briefly begin by talking about what the Yashpal Committee report, Learning Without Burden, said. And I just, to give you a flavor, there are some quotations here. The child's innate nature and capacities have no opportunity to find expression in a daily routine, which permits no time to play and to enjoy simple pleasures and to explore the world. Both the teacher and the child have lost the sense of joy in being involved in an educational process. Both the teacher and parents constantly reinforce the fear of examination and the need to prepare for it in the only manner that seems practical, namely by memorizing a whole lot of information from the textbooks and guidebooks. In mathematics and the natural sciences, the packing of details makes any kind of learning with understanding, leave alone enjoyment, virtually impossible. So you can see the echoes of many of the things which are said in NCF 2005 here. As I said, this is the inspiration. In fact, what Professor Pradhan said, some of those things also will find a reflection here. In particular, the Yashpal Committee report, which I have not quoted here, while talking about mathematics, talked of the need, even in primary mathematics, to go beyond mere computation, merely calculation, working with numbers, etc. Bring in other domains such as shapes and space, probability, and things like that. So they did open up that space, and it was, it's a very brief report, 25 pages, very little on mathematics and science, but what is there is quite important and interesting. So before I go to NCF 2005, let me sort of tell you that I have discussed in fair detail the connection between Yashpal Committee report and NCF 2005 in the written chapter, which I'll not go into here. But I'll just mention briefly that the Learning Without Burden, that's the Yashpal Committee report, reiterates many educational principles expressed in earlier policy documents. Now, what is new in the Learning Without Burden, Yashpal Committee report, is the emphasis on the child, not only in terms of the humanistic aim of fostering individual creativity and development, but also in the belief that the child's active and joyful participation is the primary driver of the process of learning itself. That is, the child is by nature someone who learns. This might be described as the coming together of a humanistic philosophy aligned to Tagore's vision of education and contemporary insights in constructivist developmental psychology. So this constructivism, if you look at the committee members, you will find psychologists, people working in education present there. And indeed, you can trace some of these roots there. So the constructivist perspective on learning, indeed, which is derived from the focus on child. So the child is very central to the Yashpal Committee report. And that's one of the cornerstones of NCF 2005. Okay, now coming to the NCF 2005 itself, this was a massive curriculum reform exercise with many leading educationists and others participating. People will recall a wide community of experts participated in the process. There were 21 position papers by the focus groups, beautiful documents, many of them written with great care, and all are publicly available, which is also very important. They offer a wealth of perspectives, and they will, I think, stand for a long time, influencing our thought and our discourse on education. The position paper on teaching of mathematics, which was one of the focus groups, identified 4 major challenges: a sense of fear and failure among a majority of children. Again, you can see that it's coming from the Yashpal Committee report. A curriculum that's not suitable to both high performers and to the non-participating majority. Crude assessment methods, inadequate teacher preparation and support. So these were challenges which were identified by the position paper. And the response of the position paper to these challenges, of course, they had some detailed responses and recommendations, but a key important thing was to propose a new vision of mathematics. I think this was a very important move, and echoed also in Principal Professor Pradhan's statements just before my talk, on mathematization and so on. So previous policies emphasized mathematics as an abstract disciplinary knowledge, which is important for the nation's progress, industrial progress, technological progress, and so on. However, the NCF 2005, as I said, had a more humanistic sort of outlook. It emphasized mathematics as a tool of rational and critical thinking and inquiry, and to serve individual curiosity and a quest for knowledge. This is based on a paper by Farida Khan. All these references are listed at the end. I will show you that, and you can take a screenshot. And if you need any help, you can also email me. Mathematics the emphasis was that mathematics should be learned not only for its utility, and the position paper distinguished between the lower aims and the higher aim, and said that the higher aim of mathematics education is the mathematization of the child's thought process. Okay, of course, this was a key word, mathematization, but what does it really mean? What does mathematization mean? And this, I think, has been a sort of point of debate and discussion, importantly so. The disposition and ability to apply mathematical and quantitative tools to understand and solve real world problems. So this might be, in some sense, the essence. One important aspect of mathematization. Some other aspects highlighted by the position paper were what we call mathematical processes. So identifying, describing, analyzing patterns using mathematical ideas and thought processes. And also, as I said, mathematical processes such as problem solving, use of heuristics, estimation and approximation, optimization, visualization, representation, reasoning and proof, making connections, and mathematical communication. So if those familiar with science education will know this distinction between science content and the process of science or the method of science. So how science arrives at scientific knowledge, what is the process? And so the method of science is thought to be as important, if not more so, in science education in comparison to the content of science itself. So a similar idea now brought into mathematics, that the processes of mathematics or mathematization are as important, if not more so, than the content of mathematics in terms of formulae, theorems, etc. that we learn. In fact, the position paper explicitly said, giving importance to these processes constitutes the difference between mathematization of thinking and memorizing formulas, between trivial mathematics and important mathematics, between working towards the narrow aims and addressing the higher aims. So so these are some indicators of what mathematization might be. Of course, I don't think there's a huge amount of clarity on what mathematization is. There are multiple interpretations and different perspectives. That's a good thing because it gives rise to some churning and some reflection. Teachers ask, what is mathematization? Tell us what it is. I mean, they ask educators, they ask researchers, they ask the policy writers and so on. And the policy writers have a responsibility to explain what it means. But despite that, I think the questioning of which is centered around this concept or this signifier, as I've said, is important because it gives rise to some reflection, change, and possible change in how we understand mathematics. Now, what did the new vision achieve? Now, it opened up the possibility for some curricular changes, definitely. If you look at the guidelines in the syllabus document, which came out of NCF 2005, you'll find many of these things. Building the curriculum around the experiences of students, emphasizing reasoning rather than just giving students finished product or formulas, etc. Developing definitions by observing patterns rather than being given ready-made definitions. Experiencing mathematics as something to be explored and discovered rather than as a finished product. So all of this is mentioned, and the textbook and curriculum writers did try to incorporate some of this. Of course, when you have a curriculum framework document, it has its most immediate impact on the textbooks and the curriculum materials, because that you have a lot of control. Whether this translates into change in actual teaching, in teaching practices, in student achievement, what happens in the classroom, in assessment tests, etc. And that's a more difficult kind of impact. It's not entirely in automatic that when you have curriculum framework changes or changes in policy documents, that these changes will flow. But certainly changes in textbooks do take place. And that's an important kind of change. We should recognize that. And one of the significant changes, in my view, that the NCF gave rise to, and this comes from the fact that NCF had a child-centered perspective. So it gave a lot of importance to how children actually think, how children learn, what is the sort of learning progression that children go through. So this also captured in the key term constructivism, because children construct knowledge. They just simply don't receive knowledge that teachers give to them, but they must actively construct them. So this whole sensitivity to the child's learning resulted in some change in the syllabus and in what one can say the learning progressions or learning strands or learning trajectories I prefer the term progression. And I've taken just one example, which is the concept of division, which I've spoken about in an earlier NCERT conference, but I thought it's important to recall that and to connect it with the changes that NCF brought about, NCF 2005. So if you look at, I have compared this NCF syllabus document with the minimum levels of learning document, which was a very influential document coming from, I think, the early 90s, if I remember right. Committee headed by Professor Dave. And this MLL document was influential in many other syllabus documents. And if you see, it's a kind of, it focuses on what they call outcomes. And for the concept of division, for example, it says that demonstrates understanding of the concept of division as repeated subtraction. So you find that this is a kind of very formal notion of division and unpacking of division for the mathematics curriculum. In contrast, the NCF 2005 emphasizes the meaning of division through activities of equal sharing and making equal groups. It relates division with multiplication and so on. So this is a slightly different approach, which makes use of contexts, contextual and situational meanings, and introduces the students through that approach. It's not, I must mention, this is not entirely new. If you go back to older textbooks, say from the 50s and 60s, you will find concepts of arithmetic introduced through situations and contextual meanings. But there was a big change in the era of modern mathematics and so on. There's another story, and perhaps we can discuss that on another occasion. This was a change brought about by NCF 2005, in some sense going back to earlier approaches which emphasize situational meanings. If you look at the division procedure, I've taken just excerpts from the learning progression. So the ML document says divides a 3-digit number, and of course goes on later to say 4-digit, 5-digit numbers by a 1-digit number, and then later on says division by a 2-digit number, and with borrowing, without borrowing, or rather the other way around, without borrowing first and with borrowing, without remainder, with remainder, and so on. So it's very focused on the actual algorithm and the procedure. While NCF 2005, it completes division facts by grouping, by using multiplication tables. It suggests that you divide a number by another in various ways, drawing dots, grouping, using multiplication facts, using repeated subtraction, or even addition for that matter, uses informal and standard division algorithms. So there's a lot of flexibility in how procedures are introduced, and there's a space for children to come up to construct their own ways of solving problems. If you look at the strand of solving problems, the ML document says solves 1-step and later 2-step problems of daily life involving division, and it adds in further classes involving division and one more operation. Then it increases the number of digits, the bigger digit numbers, up to 6-digit numbers, and so on. Now, interestingly, if you look at NCF 2005, there's a big contrast because there's no separation of division as a procedure and the problems solving in division, solving problems or word problems. In fact, everything is introduced through context, and so there's a merging of problems and situations and the learning of procedures, concepts, etc. So this is very important. You can see this in the primary textbooks. And I think it's by and large more effective. I've talked about this earlier. Particularly the division example is a good one because it's hard. It's a hard topic in primary mathematics. Many children find it difficult. And here there's a definite progress made in the curriculum change that was introduced post NCF 2005. So you can see some broad contrasts of formal definition versus contextual meanings, standard algorithm versus intuitive methods. No clear separation between learning the concept and procedure on the one hand and solving word problems on the other, but introduced through these meanings. Okay, So let me take another pause and see if there's any questions in the chat box. Okay, somebody has asked for email. I will send my email, show my email later. Okay, so no questions, but do feel free. Like I said, I will keep checking and answer questions. Okay, so let me proceed. Here are some examples of what I said. This is an example from the NCERT 2003 textbook, which is prior to the NCF 2005. Mathematically sound, very good, clear presentation, but somewhat formal. See, this is the way it's actually introduced. The division is introduced. I don't recall whether it's class 3 or class 4, but you can see also a lot of technical terminology that's been introduced. In contrast, if you see the NCERT class 4 textbooks from post NCF 2005, introduction is through situations of this kind. Dhruv lives near the sea. He thought of making necklaces for his 3 friends, looked for seashells, etc., collected some seashells. Then he wanted to make a necklace with 28 shells. And how many of these necklaces can he make? So this is a kind of what's called an equal grouping problem. And on the right, you see, which I've talked about earlier, so I'm not going to talk about in detail, a presentation from the class 4 textbook called the division algorithm, which shows a very different thing, and teachers are often confused or intrigued sometimes by what's going on and how are we supposed to teach this to students. And there's a lot of discussion of the detail in this paper of ours, which should be available on the web. Otherwise, you can write to us, write to me, where we have discussed how one teacher sort of faced a difficulty with teaching this particular method, as she called it, and what were her struggles, and how eventually she became really fond of this approach and found it very effective and powerful. And this is sometimes called the chunking method. Since I showed that, I just wanted to say, suppose you take a simple problem of dividing, say, 90 rupees equally among 5. So this is the context of a grandfather who wants to distribute 90 rupees to 5 of his grandchildren. And how much would each of them get? So first, so the children themselves come up with these methods. First, they give 10 rupees each. So, and that's in the first step. You can see that 50 rupees is distributed. Then 40 rupees remaining. Then they give 5 rupees each in the second step. So 25 is distributed. Then 2 rupees each in the next step. So 10 is distributed, and so on. And then they add up how much each friend got, and that gives you the quotient or the share of each child. Now, this is sometimes called the partial quotient method. So this does not use, like the standard algorithm, or unlike the standard algorithm, doesn't use place value. It doesn't go digit by digit. However, the meaning can be much clearer to students. And that's the great advantage of this method, that it's actually closer to children's intuition. It's something that they grasp reasonably quickly and easily. On the one hand, that's very important, but it also has the great advantage that it's somewhat similar to the standard division algorithm, and it can be a bridge to the standard division algorithm. And so this is one of the examples I like of where curriculum reform can make an advance, can make something much better in terms of children's learning. I must mention here, just for the sake of completion, that I think that the division algorithm, the standard one, is important. So it's not sufficient to just leave children with informal methods. And why is that so? We need to have a good reason for saying why the standard algorithm is important. It's important because it's extendable to decimal numbers and decimal fractions. You see, it's a very convenient algorithm and gives students a quick way to check how big fractions are, to convert fractions to decimal numbers, to calculate decimal numbers to any level of precision and so on. So the fact that it goes over and carries over to decimal numbers is one of the big justifications in my view for teaching the standard division algorithm. And decimal numbers are very, very important in our culture. And it's it's crucial that for general literacy, mathematical literacy, decimal numbers are well understood among all citizens and all people because they're used extensively in the modern world. Okay, that was an example, if you like, of sort of advance or impact of the curriculum change, the policy change of NCF 2005 on some, you could say, learning aspects or cognitive aspects of how the content is organized. So what I've later called didactic organization, I'll come to that. But there were some other things as well. This is a picture, again, from one of the textbooks. I don't remember, I think it's class 4, could be class 5. The junk seller, there's a chapter. It's a kind of thematic chapter. It's very important because it talks about where mathematics is used by ordinary people in their day-to-day work. You know, this is a woman that you see holding a mobile phone, who is this kind of entrepreneur. She has set up her own recycling shop, collecting and selling junk and recycling, very important part of our economy. And if we neglect it, it's only at our peril to our environment and so on. So it's a nice theme to choose. And it brings in some, what we can call the dimension of identity, not just of, the connection between mathematics and working lives, how it's applied in working contexts, but even identity. Now, how somebody who's just an ordinary person makes use of mathematics. And therefore, there's a meaning and importance to learning of mathematics and so on. So this is a very nice change. It again can be seen in the post-NCF 2005. I've used the term ethnomathematics because this is a very key concept which evolved in mathematics education research from the 1970s onwards. And it's a very interesting strand, and one can see the influence of that. Here is another example of a change which came about post NCF 2005, which draws in yet another strand which has become prominent in education research, which we might call critical pedagogy. That is the use of, the importance of education in training citizens to play their roles to ensure that what the democratic polity gives them is actualized. So being aware of their rights, the kind of arrangements made by the political structure, by the government, the facilities that are available, and so on. And here is an example of that. So Tulsi and her husband work on Karunya's farm. The government has said that the farm worker should be paid at least ₹71 for 1 day's work, but he pays ₹55 to Tulsi and ₹58 to her husband. So there is a question, if she works for 49 days, how much money does she get? If her husband works for 42 days, how much money does he get? Who gets more? And so on. Interesting discussion can take place. What's the money that they earn together? And this is for nearly 2 months. So is that sufficient? And so lots of things can be discussed. Of course, there are some suggested questions here, or rather suggested points of discussion. He does not give them the minimum wage. So that's important. And why does he pay less to Tulsi and more to her husband? Discuss. So these are some other elements which were brought in. And of course, they are important. As educationists, we know that education is one of the great tools, great instruments for social transformation. We have inherited inequalities, oppressive structures for over the centuries. And if you want to really transform into modern India, which was the dream of our nationalist leaders at the time of independence, when we got rid of foreign rule, to experience true freedom, so that social transformation is extremely important. And education plays a critical role in social transformation. In my view, it's perhaps the most important function in today's India of education as a whole, of general education, paving the way for social transformation. Otherwise, we will end up paying huge costs if we don't transform as a society. And here, critical pedagogy is important. And you can see that this was also something that came in I must recall that the principles of NCF 2005, which elaborated 5 principles, and the 5th of them was to encourage or promote or to foster the participation in a democratic polity. And I think this made the space for bringing in some of these changes. Okay, now you might ask this question. I'm sure you've already asked this question, that all my examples are from the primary mathematics curriculum. What about the middle school and high school curriculum? That's a very important question, in fact, to ask. And and I have some things to say on that. You see, of course, there were some important and significant changes in the middle school curriculum and textbooks. The presentation was clearer, it was more child-friendly. Some attempts were made to change the presentation, the introduction of topics, bring in some meanings, etc., particularly in the introductory lessons. You take fractions, integers, algebra. So many of these things were introduced using some situations. But however, quickly this settled down into a kind of standard curricular progression, learning progression. And this has been analyzed for the topic algebra by Banerjee, Rakhi Banerjee, in an article in Contemporary Education Dialogue. The references are at the end. She says that an analysis of algebra strand showed that the approach is still focused on procedures and does not emphasize algebraic thinking. Just as a mention, I don't want to advertise, but anyway, I think I should mention, I will be giving a talk on algebra, school algebra, and how the curriculum and the thinking about algebra could be restructured on Jan 5th for a talk for the Kerala School of Mathematics. If you have occasion, you're welcome to attend that. And that will be based on some work we did together, Rakhi Banerjee, myself, others at the Homi Bhabha Center on algebra education. Okay, but returning to what I was saying. So there was, if you go to the middle school and high school level, the changes were not as fundamental or as great as what happened in the primary curriculum. And there are some important lessons to draw from this. And let me mention a few things here. Firstly, there is a critique of the NCF 2005 position on mathematics, and particularly the notion of mathematization. This criticism has been articulated by Anjali Norona and Nidesh Soni. There's a reference there. See, they say that in making this distinction between lower aim and higher aim of mathematics, what the NCF did, or the position paper in maths did, was to promote a kind of esoteric view of mathematics. Giving impression that mathematics is something of its in and of itself. Of course, there's some truth in this. There's a beauty in mathematics as a pure subject, intellectual pursuit. Of course, Ramanujan is a great exemplar of that kind of vision of mathematics. It brings joy, fulfillment. But mathematics is also something which has powerful application. And Norona and Soni say that this has become underemphasized in this curriculum revision. Perhaps there's some point to what they say, even though it might not have been intended. But I think it's important to emphasize this, that mathematics is very powerful because of its application, not only because of its beauty. And so we need to balance both of these. And by saying that narrow aim of school mathematics is about numeracy, higher aim is about reasoning and proof and critical thinking, etc. So perhaps there's been an underemphasis, and this particularly shows up. You see, in the primary school, there is a lot of application, connections to the outside world, etc. But as we move up to the middle school and high school, it seems to become more and more esoteric, and the connection to real life, the applications of mathematics seems to become thinner. And I think this is something that perhaps needs to be addressed. in the next round of revision. Of course, the NEP has emphasized the interdisciplinary nature of all knowledge, and perhaps this can serve as a corrective. Okay, so that's one comment that I wanted to make. In response to what the Noronha and Sony have said as a critique, let me read out something. As some of you know, I was, let me read out. Yeah. So I was a member of the focus group, as some of you might know, which authored the position paper in mathematics in NCF 2005. And my spirit is that the position paper doesn't really privilege an esoteric view of mathematics. In fact, it does say that practical topics, numeracy is very important. I mean, that's crucial. It rather emphasizes the need to go beyond that. You know, not merely mathematics as a tool, as a set of formulas, etc., but to emphasize understanding, meaning, and thinking over mere mathematical learning. And it says that, so this is something that it does say, though it must be admitted that, you know, the previous curriculum had things like commercial mathematics, which were abandoned in the post NCF 2005 reform, or greatly reduced, if not abandoned. That is, in my view, a missed opportunity, because one could have changed what is called commercial mathematics to something that connects mathematics with real life, bringing in social reality. How can mathematics be used as a tool for critical thinking, critically understanding social reality, our own world, and so on. And I think that's something that one needs to pay attention to. And so this is kind of summarizing that view that mathematics is a powerful shaper of the world. Presenting mathematics merely as an esoteric subject is not tenable in general education, especially when mathematics shapes the world we live in hidden ways, and especially our social reality. And this is increasingly so. You know, all these powerful data analytics methods and techniques, the gathering of large amounts and vast quantities of data, the mathematical algorithms which are behind that. I mean, this is going to affect each of us individually because it shapes our social reality. The forms of advertising, the forms of manipulation, in fact, through propaganda, through social media, all of this is actually behind that. There are mathematical algorithms working which automate some of these propaganda tools or tools for manipulation. Important to understand that and to give our citizens also a sense of how this can affect their thinking, their choices. So hopefully in the NEP, which promotes an interdisciplinary and holistic view of the curriculum, space for this will be made. The larger goal of education, as I said, the social transformation, and the mathematics curriculum is important in achieving this larger goal. I'd just like to read this out from the Maharashtra State curriculum framework, which came out after NCF 2005. But I think it summarizes the importance of mathematics as a tool for what one might say citizenship education. So let me read this out. Mathematics is important in a democratic polity, since our ideas of fairness and justice are often operationalized in quantitative terms. For a citizen to participate in democratic decision making, mathematics is indispensable. Whether to judge the fairness of distribution of public funds, their appropriate and effective use, or to assess the impact of larger forces that shape our lives, such as globalization or environmental change, and some of the other things I mentioned. Thus, mathematics education must not only aim at making children effective users of mathematics for application in practical life or other areas of science, but must also aim at fostering criticality and precision in thinking that mathematics embodies. It must aim at building an appreciation of how mathematics informs decisions that critically affect all of society, and also an appreciation of how mathematics as a discipline builds and validates knowledge. So that, I think, is a good statement of the value of mathematics in the curriculum. Okay, so let me just pause and see again if there's anything in the... Okay. All right. So there are some questions which I'll come to perhaps at the end of the talk. Okay. So this is something that I want to emphasize sort of as the last part of my talk. Which is that there is, behind every successful reform, or if a reform is to be effective, there is some prior work which has to be done. It cannot be, for example, if we want to invent a vaccine for COVID, we cannot suddenly say, okay, now let's go and invent a vaccine. You must have a preparatory work, research institutions must be built. There must be a group of scientists who are experts in this, who've been working for very many years on molecular biology of viruses, immunology, and so on. And only then you can do research when the need arises. So when a curriculum reform initiative is announced, that alone cannot lead to changes which are effective. There must be prior background work. And this is, I think, very, very important, which we don't realize often as a society. The importance of steady professional work, scholarly work, which must be carried on over many years, which actually underlies any successful reform. And I would like to mention that behind this mathematics curriculum reform efforts, particularly at the primary level, there were many experiments which went on for years. There was the Prashika curriculum of Eklavya, which started in the 1990s. The school mathematics project of Delhi University also started in the late 90s and early 2000. The Homi Bhabha curriculum of Homi Bhabha Center, which I was involved in primary mathematics, which started again in the late 90s. The adult literacy campaign of the 1990s, which brought in some of the perspectives of ethnomathematics or critical pedagogy that I mentioned earlier. And there was a huge amount of initiatives under things like the DPEP, the District Primary Education Program, which were externally funded through World Bank and so on. Of course, there were limitations to the DPEP reforms, which were not quite mathematically sound, although they brought in some fun and games and very attractive textbooks. They were short on pedagogical insights and mathematical organization. But all of these, which went on for many years, contributed to successful and effective reform. And we should keep that in mind. And I've called this prior didactic work. So for curriculum reform, what is didactic work? It's the shaping of curricular content into appropriate ways of presentation, along with supporting pedagogical devices so as to make teaching and learning effective. And if I can recall the work, the example of the division algorithm, you see, it was shaped by what I presented was not just some idea of one person or just one idea, but it was shaped by multiple research initiatives. The Delhi School Mathematics Project, which I mentioned, tried this out, found it to be successful. You will find discussion of that in the first paper that's given there, Mukherjee and Verma, Amitabh Mukherjee and Vijay Verma, Shreya Khemani and Jayashree Subramanian, not me, somebody else, who have also written a paper about this. There's a discussion by a paper by me and Shikha Thakkar, which I mentioned. So there were many initiatives which kind of converged. And it's only when didactic innovation gets tested in multiple situations with multiple student groups, even with teachers, that one can say that it has some promise of success. And there have been such initiatives across the world, also in India. I'd like to mention the work of Usha Menon and a team at Jodogyan, which is following this Dutch tradition of realistic maths education at the primary. So there are many such, not one or two, but multiple such initiatives that are needed as a foundation for successful reform. You know, in an earlier age, such didactic work could be carried on by NGOs, non-governmental organizations, voluntary organizations, but that milieu has changed. It's no longer possible in today's milieu, I believe, in today's ecosystem, as the word is used. We need institutional basis and institutional capacity for didactic work. And where is it that we find such institutional capacity? And here, of course, NCERT plays a huge role I would really urge NCERT to take up this steady didactic work. Not just, I know NCERT has so many pressures. The central NIE has so many demands placed on it in terms of national programs, government initiatives. So they're very busy. But still they must find time for research and this sort of didactic work. The RIs are very busy running their teaching programs, very important of course, but like many other institutions, we get caught in teaching and neglect the sort of research and development work which we need to do and focus. And I hope that NCERT is one of the few places, Homi Bhabha Center is another one, we don't have too many places like that for such didactic work. Unfortunately, the NEP 2020 doesn't say anything about this prior didactic work, nor does it mention anything about education research, which is somewhat disappointing. The only place where it mentions research in education is in the context of technology. They're very aware, there are some technocrats and so on who are part of the NEP drafting. They know, and of course we know now in this post-COVID world that technology is very important. And so they've mentioned research on effective technology in education. But research in education is much more broad-based. There's a lot of research that's needed. And as I mentioned, NCERT has a responsibility here. There are some broader issues. I have not discussed that. There's no time. We can stop and take questions and maybe come back to this. But this is a lot of work has been on working with teachers and teacher specialized knowledge. How do we change teacher preparation, our B.Ed curriculum, in-service teacher professional development, and so on, bringing in aspects of both specialized knowledge that teachers need and attitudes and beliefs that teachers need about students. Okay, and I can talk a little more about these studies if there are any questions. We can come back to this. Of course, I want to finally mention the assessment issue. You know, assessment, everybody wants reform in assessment, change in assessment. But that's not easy. Assessment is extremely resistant to change. And in some sense, we all know this, but we don't acknowledge it. It's a sort of elephant in the room. And it is shaped, really speaking, by our socio-economic realities. And till those change, and educationists must realize that that change is also important. You know, the number of jobs which are available, the kind of security and stability that jobs provide. We are not in a good situation as the country as a whole. There's a scarcity of jobs which drives the intense competition for higher education in a few institutions which are considered elite. There's a massive competition for that, and that culture percolates all the way down to school, even perhaps to primary school. Particularly among aspirational middle class, upper middle class, etc. And this does a lot of damage to children. I mean, because children are busy chasing these things which may or may not yield any success at the end of it. And they lose a lot on learning, lose out on learning. Thereby, society loses out because it doesn't really have people who have learned and understood things deeply, who can bring about some change and contribute in deep ways. Or be innovative and so on. So this is something that is a much harder problem. It requires more thinking, research, more steps, initiatives, calls for changes beyond that of education and so on. So I just wanted to flag that. So let me sum up. Curricular change needs prior didactic work. Such work can also contribute to developing approaches to teacher preparation. I've not spoken about this, but I've written quite a lot. This needs institutional support and grounding, and here NCERT and other institutions do have a responsibility. Those are acknowledgements. Okay, my email ID is not there. I'll type it in and show that again. These are some references which I mentioned. I have 2 slides on references. If you want, you can take a screenshot or contact me, and this is another set of references. Thank you. Okay, so there's my email ID. You can take a screenshot of that. There's also a website link, and you are welcome to see that, and you might find some papers and other resources available there. So thank you. So let me stop here and take questions.
Good morning, sir. I am Ganesh from Tamil Nadu. Sir, may I ask the questions now?
Please do. Please go ahead.
Yes, sir.
I suppose that's okay. I think Dr. Ajit, Professor Garg, we can proceed with questions.
Yes, sir. May I ask the question now?
Yeah, please go ahead. Yeah.
Due to pandemic situation, the web learning is essential now.
Yeah.
This is the need of the hour to think about the web learning in teaching mathematics. What are the curriculum changes needed while teaching through online? That should be kept in mind, I think. What is the view about these things?
Yeah. Okay. So I must apologize for not focusing my talk on that. But there are others who have talked about this. What kind of useful techniques or useful tools are available for online teaching and learning? And you're quite right. Online teaching and learning is in some sense the need of the hour. The pandemic has taught us that. And the teachers have already been using that. So I would just like to point to you this conference which is organized by the Mathematics Teachers Association on the, I think it was around the Teachers' Day in September. And MTA India, Mathematics Teachers Association of India, has a website. And you will find some links and references. There were workshops, video recordings of those should be available, which introduce teachers at all levels, at primary, secondary and higher secondary, even college teachers, to the tools and techniques which are available in terms of software, online teaching platforms, etc. Please do refer to that Mathematics Teachers of Association India, mtai.org. I think that's the website, and you will find something there, and there will be others as well. All those resource persons who came to that workshop, they have their own websites, their own YouTube channels. You will find a wealth of materials, and so that all that is available. I'd like to just mention one of them, which is an open source software, which is GeoGebra, which is very useful middle school, high school mathematics in exploring geometry, in exploring algebra, functions, graphing, probability and statistics. Not only that, but even in online classroom teaching, you can have, if students have access to a laptop or a device on which they can download GeoGebra, you can see what they are writing on the screen. Teachers can see each of their sketchbooks, so to speak, and that becomes really powerful tool. And so this, I'm just mentioning one of the tools, but there are many such online whiteboards, online tools like GeoGebra, there's software, the projections of, and so on. So some of them you're familiar with today. We're using Google Meet, there's Zoom and other things that you're already familiar with. But these specialized things for mathematics are also available. And so that's my response in brief. I don't know if it has helped. But,
thank you, sir. Thank you. Thank you, Barbara. Thank you.
Welcome. Somebody has asked how to listen to the talk of Mr. Manjul Bhargav at 7 p.m. today. Okay, I think this is the Kerala School of Mathematics, and I think is organized. I found it somewhere. You may find it somewhere on Twitter or so. I think you do a Google search. I don't know how to post that link. But if somebody finds it on Google or Twitter, you can do a search, Manjul Bhargav talk. You can post it. Sorry, but I think it should be possible to find it. Okay. Someone has asked how to bring mathematization during the pandemic. I think my answer would be similar to what I said.
I want to say something.
Yes, Professor.
Yes, sir. Hukum Singh, sir.
Professor Subramaniam, hearty congratulations. Very nice presentation, starting from history and education and pedagogy, everything. I have few observations and want your reaction. Whatever you mentioned here that all the time we have been changing our national documents, whether policy or national curriculum for a moment, but nobody has bothered that what has been implemented and what has not been implemented. And if something was good, why it was not taken in other documents? All the time disjoint way. That I agree with you. So it means the proper monitoring has not been done. And this is why all the time mathematics is deteriorating but not improving. Whatever 50 years back we studied, same things are happening everywhere. And beautiful recommendation starting from Modalia Commission 1952. You started a bit later, but 1952 beautiful. I remember that beautiful the recommendation of Modalia Commission 1952, beautiful, but not implemented. Two policy already you mentioned, and in policy already mathematics should be visualized as a vehicle to train a child to reason, analyze, articulate, logically, everything beautiful. But again, it is not taken and carried out forwards that it is important and should be kept at the top. This is one observation. And second thing, you know, in ancient time, mathematics was considered as a very important subject and put on all the Vedanga Shastra. You know, Yatha Sikha Mauranam Naganam Mario Yatha Tadvat Vedanta, like crust on the heads of, I don't want to take much time, like us on the heads of peacock, so as mathematics on top of all the Vedanga Shastra. At that time, mathematics was considered on the top of the all subject, and now everywhere mathematics is considered either as a tool or as a subsidiary subject. Even all the organization in the country, Department of Science Center, Department of Homi Bhabha Center, or Department of this only, even NCERT, Department of Education, Science and Mathematics, exclusively the Department of Mathematics is nowhere reflected. What I am observing, I was 5 years in Europe, and you will not believe there, Department of Analysis, Department of Geometry, I was working Department of Geometry itself, Department of Topology, and here even Department of Mathematics is separately is not established in different parts of the country. And everybody talking that mathematics deteriorating, mathematics has created fear and phobia. And therefore, a proper emphasis about mathematics, that mathematics is a very important subject. It is on the top of the subject. You also mentioned in your lecture also, it is very powerful also, but not as a powerful tool, but it is a powerful subject. And if it is considered a powerful subject, it means faculty will be there, property, research facility will be there, manpower will be there, training center will be there, training facility will be there, and automatically improvement will be there. And therefore, I will request Dr. Ansuni Gar that when he is putting the recommendation, all these points should be included. That mathematics should be considered as a very important subject and top of all the subjects. Thank you. You may give your reaction.
Okay, thank you, Professor Singh. I completely agree with you on your first point that we have so many policy documents again and again, and are we simply reinventing the wheel? A new group comes and then writes another policy document. I totally agree with you, and that's what I was trying to also highlight. I think that sort of suggests that we have a responsibility as professionals in education of providing that continuity, which sometimes the committees don't provide. I mean, unfortunately so. Sometimes the committees are very mindful of the history. You know, the NCF, I think, was very conscious of the historical background, which the NEP is not, or at least doesn't show that. They say that there are a lot of background documents that are available on the website. I've never seen them, but certainly it's not reflected in the document itself. I think that missing element or component can be provided by professionals, by the professional community of education, including ourselves, the mathematics. I think we should bring it in, remind people that, you know, we are, commission alone or policy alone, document alone is not going to bring about changes. It's going to be a small intervention in a long process, continuity of where there's a continuous change. And we have to study that change and understand that change. As you said rightly, we should see what is happening at the ground level, which I have not talked about today, but what is happening at the curriculum and the textbook level, what are the changes, how do we understand these changes historically? All of these studies are very important, and many such studies need to be done. I totally agree with you. We have a responsibility, I think, so taking this occasion to remind all of us of this. Of course, the commissions have a certain role because they bring in something fresh, some new thinking, which is a compulsion because the world itself is changing. I think the world has rapidly changed since the introduction of information and digital communication technologies, information processing technology. I mean, this is a huge change in all our lives. It has produced a change in our universities, in how science research itself is done, and so on. So very deep changes, and that I think is the concern that the NEP tries to embody and bring in. But you're right, education must be seen, the new complements the old. It cannot completely dissolve or override the old. And so I think both of these things need to be brought in. Of course, I totally agree with you that mathematics is an important subject. The reason is that it is a kind of upstream subject which affects other subjects. Many other subjects draw on mathematics and the tools of mathematics. And today, mathematics is also being drawn on not just engineering kind of technologies, which are science-based, but social science technologies, as I mentioned. Social engineering is becoming a reality, and mathematics underlies that. So in that sense also, mathematics is very important. And so you're quite right. I think the community of mathematics has grown in India due to the efforts of many mathematicians. That's very nice. It should grow a lot more. And that can happen only when the citizens realize the importance of mathematics. And I totally agree there with you. And I think that's another aspect of mathematics that we all have to communicate. If you get mathematicians to give a talk to the general public, they may focus on something which is esoteric. I think that's important, no doubt. But we should also try to communicate the power of mathematics in changing other branches of knowledge, in changing our society itself. And this can also, this can in some sense come only from mathematicians who are aware of these aspects of. So all this is needed, yes. So that's my brief reaction, and I broadly agree with what you said.
Thank you, Professor. So at least you agreed, being a bit with engineering background, and you shifted to mathematics and doing wonderful work about mathematics. Yesterday, Ramanujan, Professor Ramanujan, engineering background and doing a lot of work, not a physicist even coming to mathematics. But when we talk about the nomenclature facility, everywhere we have, even 25 years I work in NCERT, and all the time I face problem. Unless proper facility, proper faculty, proper mathematics laboratory everywhere. Up now you have, I heard that you have established now Homi Bhabha being a science background and mathematics lab, Homi Bhabha center also. But when I visited couple of years, it was not there. So unless we are giving importance everywhere, we cannot improve mathematics. Thank you.
Just a correction, Homi Bhabha Center's mathematics lab was started in 1996. So I think 1995 in fact. So it's more than 25 years old.
Started about 1992. Although it took time.
Okay, next questions if anyone have. Anyone have any questions? So now I respected Professor Subramanian sir, Professor Pradhan sir, Professor L.K. Tiwari sir, Head Department of Education Science and Mathematics, Dr. Ajit Thomas, and respected participants and students. Professor Subramaniam given the detailed information about the new education policy, NCR, or and also given the how to teach the mathematics, how we use algorithm in teaching and learning of mathematics. So I really thankful to Professor Subramaniam for accepting our request, and he presented the keynote address. I again thankful to Professor Hukum Singh sir, Professor Anil Kumar sir, and our learned participants for joining the keynote address. Now, I also have one information. Today we have again 5 technical sessions. So I request all participants kindly join
according to the technical session number 3.1, 3.2, 3.3, 3.4, 3.5 through given links of the times time schedules. So really again I thankful to Professor Subramaniam, and I also request Professor Subramaniam sir, if you have sometimes you also kindly join the some groups if you have sometimes. So thank you again.
Thank you, Professor Gar.
Thank you, sir. Thank you.
So we can disconnect now. I suppose there will be a break.
Yes, sir. Sir, you have one time schedule. So there is given the individual links of the
Yes, I
individual
will
technical.
follow the time schedule. I do have some other meetings today. I'll try to join when I'm
Okay, sir. Thank you, sir. Thank you, sir.
Thank you so much and wish you all the best for the conference and the discussions and presentations. I wish I could be there. It's a very beautiful place. I have very fond memories of Shamla Hills.
Yes, sir. Yes, sir. I
Visiting
meet you,
there.
sir. Yes, sir. Thank you, sir.
Professor,
Welcome, sir.
I have only one advice. Kindly extend your lab up to class 12. That is my humble request. Up to 12. Because after 11, 12, that is the basic of the mathematics. It is a personal advice. Not up to primary or up to
Not up to level.
secondary also, because after higher secondary, the engineers, doctor, and scientists are produced. So up to plus 2 level is very, very essential.
We already extended our lab up to school, college level. We
College,
already
we are
extended
talking
to BSc level.
university, college, everywhere, but at least up to 12th class we should have everywhere. College level, I was talking to Professor Dinesh Singh, who was Vice Chancellor, and he told I want Dr. Singh, but nobody is coming forward. That is the problem.
Thank you, sir. Thank you. Thank you. So now all are requested to kindly leave the meetings and join the technical sessions, please. दूसरा चालू होगा 11:45 पे